Hi everyone, I'm Jill. You guys already know that. And me and Carly are going to be going over HeapSort today. So before we get into HeapSort, we have to um, define what a heap is. So a heap is essentially a binary tree, but it has some extra conditions that have to be followed in order for it to be a heap. So the first thing is that it must always have a heap structure, which means all the levels of the binary tree are filled up from left to right. And then additionally, it must always be ordered in a max heap or a min heap. In the case of HeapSort, it's going to be a max heap in which every parent node, including the root, is greater than or equal to its children nodes. But it's vice versa for min heap, where the parent node is less than or equal to its children nodes. So now that we know what a heap is, we can get into what a heap sort is. So a heap sort algorithm is a sorting technique that is based on the binary heap data structure. So it basically utilizes all those two extra conditions to essentially efficiently sort an unsorted array or unsorted data set. And it entails using or finding the maximum element in an array and sorting it at the end of an unsorted collection. So there are basically three steps that go with heap sort. So the first thing we have to do is actually build the heap structure itself. So we might get an array or define an array, and we have to make sure that it's in this heap structure. So we might define this function called build max heap and translate this unsorted array into this unsorted heap data structure. And then from there, we have to define, we have to swap or sync down every element so that each element is in its correct place, meaning since we're doing a max heap, it's going to be that the largest number is going to be the parent node and the smaller numbers will be the children nodes. Now that we've built this correctly, we can assume that the largest value is going to be the parent node. And because of that, we can utilize that security and switch the parent node with the last element in the heap data structure in the max heap. And from there, we would remove the 19 because it's been placed in its final place, final position, and then resort this heap to make sure and use maybe like a sync method to make sure that everything is in the correct place. So here's another graphic. So to the left, we have this, we've built this heap from an unsorted array. It's in arbitrary order, and we're going to use a sync method and essentially sync all the elements down based on their numerical value so that we eventually have this max heap with X in this case being the largest of the elements being at the parent at the root. And then to do the actual sort down, we start with this heap ordered max heap. We'd switch the X and the E, and then we'd use a sync method to sync and make sure that the new root node is the largest in the data set that we have. And then we would remove X because it's in its final position. And we keep going down and down and down and down, continuously exchanging and syncing until we have this one last element in the heap structure, and that's going to be the first element in the new sorted array or sorted data that we have, and we get this resulting sorted data. Here are some other examples. This came from this website is actually linked on Miss Elia's page. I found it very helpful. It really spelled out and had pretty cool graphics for the heap data structure. But again, we can see this swapping. 19 is at the top, swap with the last node, and then it was taken out and put set at its final position. And then in this case, to make sure, we'd use that sync method again and sync the one down all the way here. So it would be 14, 8, and then 1 to make sure everything's in the right place. And then we'd swap it with the last one again and repeat it.
So here is the runtime analysis for HeapSort. Heap construction takes less than or equal to 2n compares and less than or equal to n exchanges, so linear. And HeapSort takes less than or equal to 2n log n compares and less than or equal to 2n log n exchanges, so linear arithmetic. HeapSort is an in-place sort, meaning that no other data structures are used besides the one being sorted. HeapSort is not a stable sort. And a stable sort is when equal values are sorted in the same order as they are inputted. For the runtime, the best case scenario is n runtime, so linear. The average and worst case scenario are both 2n log n runtime, so linear arithmetic. Comparison to other sorts. HeapSort hypothetically is very efficient, and it is the only sort that is in place and guarantees a linear arithmetic runtime in the worst case scenario. However, HeapSort is not used very often in application because it's not stable, and the inner loop in practice takes longer than quicksort, and it makes poor use of memory in terms of where it is storing the data. So quicksort is often used because it is faster in practice. So now we're going to do a run through of HeapSort using the letters of the word example. First, to just go through the code, show prints each of the values in the array, exchange swaps the values using the same method we've used, setting swap equal to the value at I-1, setting the value I-1 equal to the value at j-1, and then setting j-1 equal to swap. Less is a method that returns a Boolean true or false as to whether I-1 is less than j-1, the value at each of those indices. Sync uses a while loop, and it checks if, so k is the index in question we are trying to sync, and j is 2 times k. So this if statement, the purpose of it is to check which of the 2 possible indices below the one we are checking in the heap is less. So it checks if j is less than j plus 1, then you increment 1, and also make sure j is less than n. Then you increment j by 1. And then this if statement checks if k is not less than j, or if k is greater than j, then you break, meaning that k value there has been sunk to where it is supposed to be. But if not, then you exchange values at k and j, and then set k equal to j. So the new index in focus will continue to be followed until it is sunk until the lowest point that it is supposed to be at. And here is the sort method. So the heapify or heap construction part of the sort method is a for loop where k starts at n divided by 2, where n is the length, and decrements until k is greater than or equal to 1, or while k is greater than or equal to 1. sorry, and it syncs the value at k, because that is what is done during heap construction. And then during the heap sort or sort down phase, k equals n, and while k is greater than 1, you exchange the index of 1 and k decremented, and then you sync the value at 1. And now we can run it. As you can see, the example is here in the array, and when we run it, it prints in alphabetical order. So that is HeapSort. Thank you for watching.